Um, what's it called?
Math self-efficiency. Right
Got it.
there.
Cool.
Efficacy. Thank you.
Ah, dang.
Is it coming? There.
Cool.
All right.
Let's do this.
Okay. I'll start reading.
Yes, go for it.
Compare the t-score and the z-score. What is the primary difference between the two? That one's like the formula, I think, and the difference is that the x bar equals t over s divided by not t over t times s over the square root of the sample, or n.
Mm-hmm.
Because one's doing a sample and one's doing a sample standard deviation, the other one's doing a population standard deviation.
Yeah, I think the biggest difference is just the S and the standard deviation. So.
Yeah.
Yep.
Yeah. And then with that S, he's saying that it's still a standard deviation, but it's the standard deviation of the sample now.
Yeah.
Where the other one's the standard deviation of the population.
So instead of Z, we'll use T. Instead of standard deviation, we'll use S.
Right.
Cool.
So now we have an S.
Yes, now we finally get that S.
They were trying to sneak it in on us. Okay.
Got it.
Okay, number 2. The null hypothesis is HO equals 24, or the mu equals 24, and the alternative hypothesis is the mu is greater than 24, and the population standard deviation is sigma is not known. You collect a sample of size n equals 18 and compute a mean of x bar equals 27 and a standard deviation of s equals 8. Compute the t-score using this information.
Okay. So we're doing, what's the x, the mean, 27 minus 24 over s, 8 divided by that of n, 18. Uh-oh. Did you guys get 1.590?
Yes,
Yeah.
1.591.
Yeah.
Yeah, 91.
I got that. Hey, on this next question, I had him as a teacher here.
Oh, yeah?
Yeah,
Okay.
his daughter served in my home ward back home in California.
Well, why don't you go ahead and read it if you want?
All right. It says, Shane Goodwin and other researchers studied factors that affect a student's confidence on a multiple choice mathematics exam. A group of n equals 139 students in an intermediate algebra course at BYU Idaho participated in the study. In addition to making their test question responses, they evaluated their confidence for each question on a scale of 1 to 6. And those are them. Confidence ratings are not relayed to the instructor, and they did not affect the grade on the exam. The mean confidence rating marked by each student is given together with their score on the exam. The maximum score possible on the exam was 100 points. Use the file, or open the file and use this information to answer questions 3 through 5. Cool.
Huh. All right, what is the mean? So, let's see. We go to analyze, or are we doing?
You go analyze, descriptive statistics, and explore.
Mm-hmm.
And we want, what are they looking for? Looking for
the mean.
the scores on the exam. So we're looking for score.
Scores. Yeah.
All
You
right.
have to be careful because the next one asks for confidence, and I was like going through the homework. I'm like, oh my gosh, why can't I get this answer right? Because I kept looking for score, and it was looking for the confidence.
Okay.
Yeah.
And we just keep it on both, or should we go to statistics?
You
You
go to
can't-
statistics.
Down.
Oh, I just leave it on both.
Just leave it. Okay, go to statistics, and then is it at 95% or does it matter?
Oh, we're not doing confidence interval yet. We're on 3.
Oh wait.
Yeah, you're just
No,
trying
I
to find
didn't-
out the mean score, so you just need to go to that analyze.
Wait. I just pulled over score to the dependent list,
Mm-hmm.
and then do I just push OK then?
Yeah.
Oh,
Yeah.
okay. I was going into statistics.
Okay, so is the
Okay.
mean 74.72?
Yes.
Okay. And then it gives me the 95% confidence interval already.
Right.
So is it 71.9 and 77.5 or 46?
Yeah, it says 71.98 and the 77.47.
Cool.
Yeah.
All right, where did y'all go at the SPSS thing?
Okay, so you
Okay.
go to Analyze,
Uh-huh.
Descriptive Statistics, and then Explore, and then you move the score over to the dependent list, and then you just click OK.
You getting it, Eddie?
Yeah.
Cool. All right.
Next one. Maybe we will get done before I have to go today. Let's see.
Hopefully. It was only 15 questions. All right.
Find and interpret a 95% confidence interval for the true mean confidence rating expressed by students on the intermediate algebra exam.
So this is where you're going to have to go back and change that. You're not doing the score, you're doing the confidence rating.
Okay.
Okay.
So,
Now we just go all the way back, descriptive, and then now we pull over the confidence rating to the variable,
Yeah.
and then I'm just pushing OK.
And then most likely you'll get both. So you'll have the score and now you'll have the confidence.
What was that again?
wait, what do you do?
So did you go right back up and do the analyze, do the
And then
whole
I went
thing and
to
explore, and then you pull over the confidence rating?
Oh,
Oh, you
whoops.
pull over confidence rating too?
Yeah.
Okay. Cool.
Yeah. Okay. Confidence. Let's see. Where's it at?
Oh, I see that.
So now you have both of them.
Mm-hmm. Just
I think
confidence.
lots of times you should just pull over everything in the beginning,
I know.
just to
It's
make
true.
it quick. For whatever they have, just do it.
Yeah, because I kept doing it. I'm like, why can I do this? I was like,
Okay.
oh, it says confidence.
So right there, is that 71, the lower bound and upper bound? Is that what they're talking about?
No,
No,
you're looking at
confidence.
4.257 and 4.571.
It's one of them
Rating.
says score on the upper left, and the other one says
Uh-huh.
confidence rating mean on the upper left.
Okay, I'm scrolling down to see. Oh, confidence rating mean
Mm-hmm.
down towards the bottom.
Yeah. And then it says the 95 confidence interval for mean.
That'll be 71.98.
No.
It's
That one was for the score. Here,
Yeah.
let me.
Okay,
We're doing number
the
4, right?
confidence rating mean interval for the confidence rating expressed. I went all the way down to the bottom, and
5.
it says confidence.
Oh, I was
And-
telling Eddie we're on 5.
Okay, I went all the way down. Stem leaf, but it's not a. Are you guys all the way down to the almost the very bottom, right before the last box plot, or?
No.
Eddie,
I'll
did
show
you buy the software too?
Nope.
How are you doing your Hangouts on Air and being on it too?
As I'm like behind.
Because I got on the Hangouts on Air, but every time I went to talk, it wouldn't recognize my microphone and it wouldn't let me install it.
Oh, I'm on the phone.
Oh, I
okay.
see. So I'm the same thing. You guys are on the iPad and I'm using my laptop for it. So the lower bound is the 4.2566. Is that the confidence interval mean, that 95%? You guys are
Yes,
looking at the
yeah.
same thing.
4.256.
4.257 and 4.571.
Yeah.
Did you find it, Eddie?
Yeah.
Okay.
Okay. Let's move on.
Okay, 2 years ago, in a similar study, the mean student confidence rating on a scale from 1 to 6 was found to be 4.12. We want to know the mean confidence rating of math students has gone up in the last 2 years. Do a hypothesis test to see if the new study has a mean student confidence rating that is significantly higher than 2 years ago. Use 0.05 as your level of significance. Use the information to answer questions 6 through 12. And then for 6, it says, what are the assumptions that should be met to conduct the hypothesis test? And are they met? That the one is that the data is collected by a simple random sample, and then it's normally distributed, right?
Yeah, so it's like, or the random set, we assume that it's true.
Yep.
It's normally distributed.
And then the 7's easy because it's just an alternative hypothesis where the H
One's
is
equal and one's greater.
Yeah.
Mm-hmm. All right, and 8, compute the sample test statistic. So,
Okay. The T.
are we still using the same numbers?
We're using these numbers from this 2 years ago similar.
Okay.
Or wait. Where are the numbers at?
That's
What numbers are they? So I'm just writing down this. It is X minus U over S. Wait, if we're doing the T statistic there, yeah, over that.
S, yeah.
Okay. So what numbers are we using here? 2 years ago, a similar study mean found
to be 4.12, right?
the scale from 1 to 6.
What?
And the mean confidence to the hypothesis. Yeah, it's like there's no numbers to use. So if they're saying a similar study, do you think we use the same numbers from the numbers before?
Study, we're changing the X bar. The X bar will be the 4.12 they give us, and the mean for the last test survey will be the normal mean.
What?
Yeah, so the mean will be for the last survey, and the mean that we have here will be for this survey.
Oh, so the mean that we had on the one on the other page. Is that what you're saying?
Yeah, the mean we had on the other page, what was it again?
The mean was
74.
Oh, on the what we found on the mean is
on the
74.72.
74.72 over what is the sample?
What is X bar? Is that the 4.12?
That's what Eddie thinks.
Yeah.
Minus 74?
It's going to be a negative number.
Yeah, it's going to be a big negative number.
Um,
In a similar study, the mean student confidence rating. Are we doing the confidence rating? We're not doing the score. The confidence rating.
Compute the sample test.
let me try to find the z-score on this sheet really quick. Or the t-score. Oh, test value says 247. Okay. Oh, wow. I got a really big negative number.
What? But we're not doing the score. We're doing like the confidence rating, which was 4.12. If you go back to number 5, and we're talking about the intervals of the confidence ratings. When I can't pull up my SPSS. If we're just doing the confidence rate, what was the mean on the confidence?
The mean for the confidence is 4.41.
That's what we're going to subtract from.
So
you're saying to do, you guys, this 4.41 minus
4.12 minus.
Yeah,
4.41.
Yeah, 4.12 minus 4.41. And the square 139. And then what is the
do we still use 8 over the square root of 18?
Yeah, what's the sample? The standard deviation sample.
It says it was a similar study.
Okay,
So
let's
we'll
go
just
back
do
up.
8 over. Does the level of significance, the 0.05, play a part in this? If that's not the.
No, that's what it needs to be. If it's under that, then it's rejected. If it's over that, it's not rejected.
That's the alpha.
That's the alpha. So what is the sample?
Yeah, what do we do in the square root of sample?
So what we were doing is wrong. Compute the test sample statistic.
So if you put this into SPSS, does it just give you the t-score?
It does, but it's not the same one. Let me try it a different way really quick.
So if it's 4.12 minus 4.41, what would S and N be? N is, what's the, I'm trying to see in this.
Dude, they better not have stuff like this on the exam. That's confusing. Well, I'm wondering if we use the same as before, like 139 students.
Yes, that's what I'm thinking. It's 139.
Did you already try that, Catherine?
No, I was going to try 139 right now.
What's the sample,
No, that's
though?
wrong.
It says, so the mean is 4.41, N is 139.
What's S?
39?
What is
Yeah,
that?
because that's the sample of the students, Eddie.
Yeah, so we'll use, for the new one, we'll use 138.
138? Oh, yeah.
Minus! Remember N minus 1? Oh, you guys are smart.
But what is S again? Like, what?
We were doing 8.
It was 8?
Let's see if that's right.
Because N will be
Let's see.
138.
What is the mu again? You got. Oh wait, I got it right here. 412.
Hold on.
4.12 over 8. 138. Let's try that. Well,
It's still wrong.
either I didn't get it right or I got it totally wrong. This is a question. Dang. Do you guys want to go on and come back to it or keep trying different things?
I'm going to try
Well,
just a minute.
we're going to need to know how to do the T-score for our quiz.
Let's see. I'm gonna.
Why can't I figure this out? It's so frustrating.
Why?
I'm going back into my just BYU, and I'm gonna go to one of their videos.
And see if someone's done this one yet.
Yeah, I was gonna see which one's a T-score on the prep assignment. I just did all the prep assignments with the redhead dude.
Mm-hmm.
And I'm gonna see if there's a little clip where he does it. And then conducting. Okay, number 5.
Question 5.
Do you guys want me to show you this little video?
Sure.
I can't share the screen because you're not on it, but I'll do this, like old school. Let's see.
When conducting a hypothesis test for a single mean with sigma unknown, what is the formula used to compute the sample test statistics? Okay, here again, very similar to the PPT, but just a few minor changes. So we still have our x bar, and we still subtract our mu, but this time we divide by s, which is the standard deviation of our sample, and then square root of n. Just a little bit different.
Okay, we know that.
Question 6.
No, but tell
What are
us
the
like
top-
what to. Okay, that wasn't helpful. Let's see here. All right. Never mind.
I think we're putting in wrong numbers, and I don't know how. Get this sample.
Well, I don't even. Yeah, we definitely put it in wrong numbers. I just don't know what numbers to put in.
So it says 2 years ago in a similar study, the mean student confidence rating on a scale from 1 to 6 was found to be 4.2. So is it 4.12 minus 6? Or
No, because the scale's 1 to 6 up there. That's your confidence rating. Like if you go up to right before question number 3, it's talking about that confidence rating. It's just 1 to 6. A group of N, which is 139 students in a media algebra course at BYU, participated in the study. In addition to marking their test question responses, they evaluated the confidence of each on a scale of 1 to 6. So, what's the sample? I know it's 139, but what's over the 139? I think that's where we're missing something.
That 8.
Where did you get 8?
it's from the previous problem.
How many people are in this study on your thing?
There
And
are 138.
number 3. Yeah.
Okay,
Or
so
no, it says 139 on all of the
139. We tried 139, then we tried 138 because they were saying somewhere that it's that number minus 1.
We have the group, which is the 139, but what's over the 139? What's the number going to be? Let's see. I'm trying to
The
look.
sample deviation.
Yeah. Let me see if I can find it anywhere in their homework.
And
if you put it into SPSS, it's not giving you the T-score. It is giving you a T-score, but it's not that one.
No, it's not that one at all.
Okay, let's see.
I got the answer.
How'd you get the answer?
I got the
really close to the answer, I guess.
What'd
So I
you
did-
try doing?
I got 4.12 times 4.41 divided by 0.93854.
How'd you get that?
That is the standard deviation of the confidence rating mean.
Tell me those numbers again. And what was your answer? Did you get the t-score?
And then you divide by the square root of 138, and I have negative 3.63.
But it's not a negative. That's the problem.
No.
So the standard deviation of the confidence rating mean. How did you get that?
Hey, my kids just came home. I'm just tell them hi.
How to get the
Hey, you guys, I'm in the kitchen.
deviation of the confidence rating?
How'd you get the standard deviation of the confidence rating?
It's on
Okay,
the
well, we better
IPSS.
get some eye drops in.
Is it on the?
Yeah, is it in SPSS, the standard deviation?
Are you so happy?
Oh, it is. Yeah,
And what is it?
it's 0.93.
Okay. You actually have
854.
2 orthodontist appointments this afternoon at 3, so you'll be done by 4. Okay? You guys can do stuff on that, but I'm using these two.
Can you open grades?
Not right now. Can we do it later, please? All right. I love you very much. Go take care of yourselves. Question 8. Did you guys find any luck how to get that to be a positive?
It shouldn't be a negative. It should be a positive number because you're multiplying, right?
So are we subtracting the 441 from the 412? 412 from 441. Hold on. 412. I don't know if that should be flipped. What's X bar?
Yes, you guys just have to work it out.
What's the answer?
3.693.
Hmm.
Well,
Did you multiply 4.12 times 4.41, Eddie, or did you subtract?
You subtract. Because the formula is t equals x bar minus the mean over
Yeah.
s divided by the square root of n.
okay, well, I'm okay if we go on. Lots of times I think I found also errors in this homework before. Like, remember they had the n like double, like 2 times or something, and so I'm wondering if there was some kind of, I don't know.
No. I got a positive number. I got 3.629.
And what did you do?
I just switched I did 4.41 minus 4.12.
Yeah, because I got 3.643.
So we're all super close.
Okay, so let's just go move on and see what happens. And then the stated degree of freedom is just the -1, which is 138.
Okay.
The
p-value and compare it to the level of significance. So does that mean we have to plug it into the applet?
In the video with the redhead, he said that we can for when we're getting the P. Let's see. It's a little. Can use applet when we're using the p-value.
So we need to find the z-score. So
The
z is
z-score
equal
will be
to.
the 3.693.
That's a t-score. The z-score is a population mean, not a sample mean.
So
So it would be x bar, which is 4.1241 over.
Isn't the p-value on your SPSS?
Oh yeah, it is actually.
If you look, yeah, you don't have to use applet for anything on this. So if you go down and you look on the bottom of the, it'll say. It's on there. I wish I could get my note. Next time I'm gonna have another laptop available.
It's under the what's it called? I know it's. Let me show you. It's under the sig two-tailed thing. You divide it if it's only one.
And yeah, if it's double-sided, you divide it by 2. But we're trying to find out if it's greater than, so it's just one-sided. So we have to divide it by 2.
It's 0.000. That's the answer they gave me.
Where are you at? I can't find the
where'd you find the p-value?
It says sig.
If you right-click on that one, well, you can't do it on that one. The p-value is 0, 0. So that means that the alpha is still bigger. So it's smaller. I'm sorry. So then we reject the null hypothesis if it's 0, 0, 0.
Oh yeah, so right, that is the p-value then.
Yeah.
Because the p-value, it says it's 0.0001.
Mm-hmm.
So then that is the right answer, and it's less than the 0.05.
Can you guys just kind of, let's see, where's this? You're just saying it says sig?
It says, did you do the t-test thing?
Oh no, I just went into. Let's see. So did you do the same thing, descriptive, then explore?
No.
You do analyze, compare means, and then one sample.
There it is. They showed that. Okay. Okay, and then the confident, or what'd you pull over? The score?
It's confidence.
No, confidence interval.
And you said compare means one sample?
Yeah.
Compare means one sample t-test, yeah. That makes sense.
Less math.
Yeah.
Okay.
If you do that T one, does it tell you the T score on that one?
Oh.
It tells the t-score of 55.447.
Will you go get me my plug-in for this, please? For this. It's in my bedroom. You guys, I need an extension cord. Can someone please get one from the room? Please?
So for number 12, basically, since we are rejecting the null hypothesis, we have sufficient evidence that the confidence interval thing is less than the level of significance.
And bring me the extension cord, please. It's hooked to the plug-in. It's white.
Okay. Should we go to 13?
Yeah, let's do 13.
All
I'll
right.
go ahead and read it. A group of students carefully scrape the white filling, the stuff, from traditional and double stuff Oreos. They took about 50 samples of each type of cookie and measured them in grams. The amount of stuffing in each cookie to determine the double stuffed Oreos really contained double the amount of the filling. Open the file, data that, to use it. I'm laughing because we just bought some double stuff.
Okay, so that's the one. And when you have to plug in the 90% confidence interval.
Yeah, I'm opening it up right now. All right.
Okay.
Got it. All right. So, are we looking for traditional or Oreo or double stuffed?
Let's see. Took about 50 samples of cookies. To determine if double stuffed Oreos really contain double the amount of filling. Open the data file Oreo double stuffed. Use information to answer. Find and interpret a 90% confidence interval for the true mean weight of the filling in traditional Oreo cookies.
Traditional. Okay. Cool. Nope, don't do that. Cancel.
Okay, traditional, and we have to make sure it's at the 90%.
Right.
Yeah.
You're saying, so do we need to go into statistics then?
Yes. Yeah.
Okay.
And you plug in your 90.
90
Is it
instead
default
of,
95, right?
yes. Okay.
So is the answer 2.808 and then 2.988?
Yes.
Okay.
That's what I have.
All right, and then now we need to do for the double stuffed.
Mm-hmm.
So analyze.
Oh, remember, we just should do it for all of them.
And then double stuff. Is it 90 again?
Yes.
Okay. Is that one 5.591 and 5.920?
Yes.
Okay. And then based on our observations, I would say yes. 2.8 times 2, 5.6. Yeah. I'd say it's either half or a little bit more than half.
Yeah.
Cool. All right. Sweet. All right.
Okay.
Start the quiz.
Yeah.
That's good.
You're finished. Man, I barely got into the SPSS.
You barely got into SPSS. Do you want to
Well, bring it up for the quiz.
All right, let's do the group meeting quiz.
Ooh, this is when it's tricky. I'm going to do the quiz while in SPSS.
All right, there's 16 or 14 questions.
You're doing homework quiz for
No,
11, a group meeting quiz.
yeah.
Group meeting quiz for lesson 11. Hopefully there's, how many questions? Let's see.
There's 16.
Hopefully it'll go fast because I think it's all plugging into SPSS.
I hope
And
so.
when we do it, we should poll over our different options so they're all just there.
Yeah.
Okay. All right. In previous lessons, we had assumed the population standard deviation, sigma, was known. In this lesson, we are making a different assumption about sigma. What has changed?
That is unknown,
Yeah.
right? A.
Mm-hmm.
Yeah.
Okay. All right. For the next two questions, let the null and alternative hypothesis be u equals 8 or mu is greater than 8. Assume that the population standard deviation is not known. Becca collects a sample of size n 9 and computes x bar equals 11 and s equals 6.
Okay, so is sigma known?
It says not known. Is that just a straightforward answer?
So are we just saying no? Yeah,
Uh,
why not?
I think that's a trick question. What is the value of t? So t
Okay.
from
So
here,
now we do.
T equals x bar. Do they give us x bar? Is
Yeah.
11
x bar is
minus
11.
they
Where's
don't.
mu is 8,
Oh yeah,
and then your s is 6.
6 over.
But what is the total? Oh,
9.
total is 9. Okay,
Yeah.
awesome.
Okay, 1.5. Is that what you guys got?
I'm doing it.
Me too.
Yep, I got 1.5.
Yep. 1.5.
Oh yeah.
Oh, we need the SPS or the body temperature. Did you do the body file temperature one for your? Oh, it was in the homework or the prep work. I can't remember.
Is that one of the files? That we
It is. Yeah,
Okay.
it's a data file.
Body temperature. Got it.
How about a couple of us go into it and the other person tells us, or I guess we don't need to have all the numbers.
What is X bar is what we're wanting to know. Use the following values, copy and paste. Use the null hypothesis of 98.6, and we want to think that mu is less than 98.6 and the level of significance is 0.05. What is X bar?
Okay, so are then. Oh wow, this one has a lot more numbers than.
Yeah.
So I'll just plug them in, and you guys tell me what they are.
Okay, you've got the SPS up.
Yeah, just give me a
Body
sec.
Oh, I've got it right here. So, Donna, I'm just doing the test in SPSS. Like went to just BYU Idaho. Anyway, that's how I'm kind of going back and forth.
I can get into the BYU Idaho. I can get everything in with SPSS, but they don't allow, because you're on a different network, you're on their network, they don't allow you to use your microphone or your screen camera.
Do you have multiple? Do you have a Mac?
No.
Oh, okay. Because if you had a Mac, I could tell you.
I need to get my daughter's laptop and set it up so I can just be on Google Hangouts on her phone and use my computer for the SPSS.
Yeah. Okay, can someone read me the numbers?
98,
Mm-hmm.
99.6,
Yep.
97.8,
Uh-huh.
97.6,
That's 6.
98.7,
Mm-hmm.
98.4,
Uh-huh.
98.9,
Mm-hmm.
97.1,
Yep.
99.2,
Mm-hmm.
97.4,
Mm-hmm.
99.1,
Yeah.
96.9,
96.9.
98.8,
Mm-hmm.
99.9,
Yeah.
96.8,
Hmm.
97,
Yeah.
98.7,
Mm-hmm.
97.6,
Yeah.
98.7,
Mm-hmm.
and 98.2.
2. Okay. So we are looking for the mu. So analyze, explore.
You're looking for the mean?
Yeah.
98.22.
Did you do it by hand?
Yeah.
Let's see. The mean is 98.22.
So that's X bar,
I think so.
98.22.
Good job, you guys.
98.22. And then what is S?
Down to 3 decimal places. It's 98.220. So it's 98.22. Yeah. What is S? S stands for.
The standard deviation for the sample.
It is 0.922.
22.
0.922, yeah.
And then what is the T-score? That should be on there too.
I haven't solved for T-score yet, so I will now analyze. It is Does it say any percentage it wants it at? Just T-score?
Round to 3 decimal places.
Ooh. It's a really big T-score. Probably wrong. Let me try it again. Analyze, compare. In the video, did you guys see that it wanted the test value to be 47?
47. Oh, you need to put 98.6 in somewhere, don't you?
Is that, analyze, compare means.
So when you put in your, I'm trying to think where it is.
Point. On the confidence interval percentage? Or on the test value?
Let me see where I can remember where they said to put it. You need to put it on your test value.
Test value?
Yeah.
Okay, so it is 98.7. What was it?
98.6.
This is for
98.6. Okay. Cool.
Is that what the T-score is?
Our T-score is now negative 1.843.
Negative, say that again?
Negative 1.843.
Sorry, negative
What?
8.4.
Sorry, what was your math on that?
Oh, I'm just doing it on SPSS.
Okay. What did they use for N?
So
N is 20.
It's not N minus 1?
Are you talking about the DF? The, what's that called? N minus 1 is the degree of freedom, yeah.
Don't we have to use that for...
No, you don't use that unless they ask for it.
Wait, you guys, I don't know where you are. Where are you at? What was question 8's answer? I didn't hear you. The T-score.
I got negative 1.843, but I don't know if that's right.
So for the T-score, it might be because on the homework it has a negative also for the body temperature one.
Okay.
Because you go to analyze, compare means, one sample, t-test, and then when you go there you pull over the body temperature, the test value is 98.6. and then you hit OK, and then your body temp, it goes the T, the DF, the SIG, and the mean difference. And the T, and our homework assignment was, or in the prep work, was a negative 6.029.
Okay, so
See, I did,
So negative.
if you
Go
do it,
ahead.
if you do it over the square root of 19, it's negative 1.796 or 97. And if you do it over the square root of 20, you get negative 1.843.
But you don't have to do math. You're just using your SPSS.
Well,
Yeah.
Eddie, why don't keep those figures in case we get that question wrong. Okay.
the one that SPSS gave us is negative 1.843.
So I say that one's probably correct.
Okay.
Yeah.
And then I'm gonna plug this one.
Is
That
this a-
T-score. Uh-oh. I can't.
Is it a one-sided or a two-sided?
One-sided.
Okay, so 0.0081 divided by 2. The answer for the next one is 0.041.
Okay.
0.041.
Mm-hmm.
Okay, what is the
Say
correct
that
decision based evidence?
1041.
0.041, yeah.
Well, we're gonna reject the reject it because it's smaller than the 0.05.
We are going to, yes, you're right.
Reject. Sorry, the p-value you put 0.041.
Yeah.
Okay. And we're rejecting it. Uh-oh, whole bunch of numbers again.
All right, let me,
With the level of significance of the area.
okay. What are the numbers?
Okay. 59,
Uh-huh.
14,
Yep.
37,
Mm-hmm.
62,
Mm-hmm.
8,
68.
58,
Mm-hmm.
2,
Yeah.
15,
15.
9,
Mm-hmm.
157,
157.
27,
Mm-hmm.
37,
Mm-hmm.
2,
Yep.
55,
Mm-hmm.
86,
56.
6,
Uh-huh.
14,
Yep.
4,
4. Uh-huh.
40,
Mm-hmm.
36,
Mm-hmm.
47,
Yep.
9,
Mm-hmm.
61.
And that's it?
That's it.
Okay. Let me make sure I got them right. Okay, it is 68. Oh, it's 86. Okay. That one is 86. And then 14 and 4. Okay. 47, 9, 61. Okay, cool. All right, what are we finding?
We need
The
to find the
p-value?
p-value. Yeah.
Analyze. Do we have a test variable for this? Or test value?
Let me look.
No.
At 40.
It's
Or,
40?
What does it mean?
Oh,
I'm
the
sorry.
null hypothesis, the mu, is 40.
Yeah.
And
So that's the test variable then.
Yeah.
Okay, so it's 40.
versus 40 minutes.
Okay, so test value is 40. All right, moving that over. All right, so
It's a two-sided because it's the not equal to is not greater than less than, so it's two-sided.
it's two-sided. So
Uh-huh.
the answer is 0.995.
.995?
Mm-hmm.
Yes. And
And
what decision would you make?
Reject
Fail,
the null.
fail to reject because the level of significance is a 0.01 and is greater than that.
yeah.
Reject.
All right, you decide to try another alternative hypothesis. And this time you use that. So,
You do half of your p-score.
so it would be like 0.5. It would still be greater, but the p-value would decrease.
Okay.
And you would still fail to reject the null hypothesis, right? Because it's
There's
still
a
greater.
0.01.
Still above.
Yeah.
Now construct a 95% confidence interval with the true mean wait time between births at a hospital. So now you need to plug in the 95% on the statistics. What is the lower limit of the confidence interval?
All right. Let's do this real quick. 95?
Yeah.
Yeah.
Okay, so the lower limit is 23.499.
Oh, round to 1 decimal place. Sorry.
Oh, so 23.5.
Okay.
And the upper limit is 56.6.
All right.
Do you need
Who
any
wants-
numbers, Catherine?
Nope.
Or did you put all your answers in?
I did, yeah.
All right. I'll go ahead and submit.
Okay. Hopefully we'll get it.
Yeah.
What y'all get for 15?
15, 23.5.
And for 16?
56.6. How'd we do,
100%.
Marge? Did we really?
Yee-hoo!
I get to go to the orthodontist
On time.
with my 8-year-old. She's got super messed up teeth. All right. Sweet.
Sweet.
Great.
Catherine,
Thanks.
thanks for plugging in all those numbers.
Yeah, for sure.
Donna,
Hey,
thanks for telling her. All right, you guys.
I'm wrong.
I'm going to let you guys go.
What'd you say, Eddie? You got one wrong?
I got 2 wrong.
Okay, I'll go through them with you. I don't have to get off. What did you get wrong?
Bye, guys.
Thanks.
Guys.
See ya.
Let's see here. Yeah, I got 14 and
14 is fail to reject the null hypothesis.
and 5.
And
five.
5 is 1.5.
Okay, want to go through and put your answers in again? We'll help you.
Okay.
Mhm.
Let's see.
That was easy.
Yes, all SPSS.
Yeah, so just one question. So when doing let me get it really quick. When doing the test value is just the
It's the mu.
equals.
Yeah.
Okay, that's all. That's good.
If you go to, I think it's like, in the homework, it's like on, just so if you want to read it. Oh my gosh, it's not really labeled. But I printed mine out. It's on page 4, but it's on the hypothesis test section 3, step 4.
Okay.
Just so you can look. I don't know if you wanted to look at it or not.
Yeah, I'll write it down. I don't have it open yet.
What was the answers again?
Okay, number 1 is, oh, you already did that, true. Number 3 is A, we assume sigma is unknown.
Okay.
Number 4 is no.
Okay.
Number 5 is 1.5.
Okay.
Number 6 is 98.22.
Okay.
Number 7 is 0.922.